universe or simulation we're in doesn't render the states of quantum particles until they are observed, conserving its computational power. The double slit is a famous experiment in the realm of quantum physics. It's often used to showcase the bizarre behavior of tiny particles like electrons or photons when observed. Imagine you have a wall with two narrow slits close to each other. Beyond this wall, you place a screen. You then shoot tiny particles, like light or electron, at the two slits. If you think of these particles like tiny bullets, you'd expect that after shooting many of them, you'd see two bands or clusters of hits on the screen, aligned with the two slits, right? After all, the particles should just go straight through the slits and hit the screen behind. But here's where things get weird. Instead of just two bands, you see multiple bands on the screens, as if the particles are behaving like waves that interfere with each other, like ripples in a pond. This is odd because you're sending individual particles, not waves. But here's the twist. When you try to peek and see which slit a particle goes through by placing detectors on the slits, the interference pattern, the multiple bands, disappears, and you get the expected two bands or clusters on the screen. It's almost as if observing the process changes it. When you're not trying to directly observe or measure which slit the particle goes through, it seems to behave in this strange wavy pattern, creating multiple bands on the screen, as if it's going through both slits at once. But the moment you put a camera, a detector, at the slits to see exactly which one the particle goes through, the particle chooses one slit. In essence, just the act of trying to watch or measure the particle seems to change how it behaves. This is one of the most puzzling aspects of quantum mechanics. The double slit experiment challenges our everyday intuition about the nature of reality. It suggests that particles can behave both as particles and waves, depending on how you observe them. This dual nature and the role of observation are foundational aspects of quantum mechanics, making the double slit experiment a cornerstone in our understanding of the quantum world. It's important to note that while the analogy between video game rendering and